Software Engineering Radio, episode 97, interview with Anders Hejlsberg.
This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for supporting the podcast.
Okay, welcome listeners to another episode of Software Engineering Radio. This is another one recorded at Microsoft in Redmond. This time we're talking to Anders Hejlsberg. Welcome, Anders.
Thank you.
And we're going to start with some historic stuff. Anders has been involved with Pascal a while ago. So, how did you get into Pascal back then?
It was actually sort of in high school. Back in the sort of later 70s or mid late 70s, our high school had what was then called a mini computer. Mm-hmm. And on that mini computer, we could program in Algol. And so I was that was the first programming language I was taught, was Algol. And then when I got out of high school and into the technical university, I met up with some buddies there, and we started a company, a small, company to sell kit computers and make software for kit computers. And I wrote assemblers and disassemblers, mm-hmm. and all of this kind of stuff that you would write for those. And then wanted to write more of a full language compiler, and I wanted to write an Algol compiler, mm-hmm. because that was what I knew. And but then my friend was going, there's this new thing called Pascal, you should take a look at it, And so I did, and then it was actually simpler to implement than Algol. So that's the way it went, Yeah. And then of course that was actually the first Pascal compiler I wrote was the early precursor of Turbo Pascal, and it was mm-hmm. all written in Z80 assembler, mm-hmm. and it was 12K, including the compiler runtime and an on-screen editor for this kit computer called NASCOM, which was a British kit computer. And you could yank out the Microsoft ROM BASIC and then stick in our little Pascal compiler. When you turned the power on, you were sitting in an editor. You could type code,
mm-hmm.
So.
Mm-hmm. Yeah, Pascal was actually the first language that I started with BASIC on the Amstrad CPC.
Mm-hmm, mm-hmm.
And then at school we had Pascal, I think it was Turbo Pascal 3 thing, on Zenith computers. Very old stuff.
Oh, so yeah, I remember those. Yeah.
That was, and I remember the time when I couldn't imagine how you could program without line numbers. I was really, I didn't know how that would work.
What are you going to go to?
Yeah, exactly. How do you point there?
Yeah.
So anyway, so what's the state of Pascal today? Is it still used somewhere, or is it?
It's still, Turbo Pascal is still, or its predecessor Delphi, successor Delphi is, I think, still used in education in. I forget where, but I saw a write-up of it a couple of years ago, and certainly then it still was. Mm-hmm. Although I would say it's on the decline for sure.
Yeah.
But Pascal evolved over many years and, sort of sprouted object orientation and sort of become a fairly full-fledged language. It never really made the jump into the sort of VM world and bytecodes. Well, that's actually not entirely true, because UCSD Pascal was really, in a sense, the grandfather of all the bytecode systems, because it had P-code and ran P-code. So if you had the Apple II had a great implementation of UCSD Pascal and the P-code system.
So I didn't know that.
Yeah.
It's also not typically cited as one of those precursors to the Java VM. People typically talk about
it's probably because it goes back too far, but it was certainly for me a great inspiration in Turbo Pascal. Yeah.
So you already mentioned Delphi. I used it quite a bit. Wrote a couple of hospital data management system with it. Delphi 3 or something. So why do you think Delphi was so successful back then? I mean, it's obvious competitor with Visual Basic.
Well, I mean, I think first lots of credit goes to Visual Basic for sort of inventing the GUI RAD tool, you know, and I think that was fantastic. But Visual Basic had all sorts of issues. You know, I would say it was in many ways popular in spite of the fact that it was basic, right? I mean, there was a market there for more, you know, I'd say industrial strength language with a real compiler and native code and, you know, real modular compilation and blah, blah, blah. And so we sort of married, if you will, the radness of that with a real compiler and then a great extensibility model that allowed people to build new components very easily. I mean, if you remember, Visual Basic, for example, did not support inheritance, and you could not create new components by inheriting from other components. In fact, you couldn't really create new components in Visual Basic to begin with. You had to write them in C using a very complicated SDK where Delphi was written in itself. And you know, that was actually, it was a great dog fooding experience. You know,
yeah,
so.
That's always useful if you can do that. Yeah. So what were some of the language features of I think it was called Object Pascal at that time? It was obviously object-oriented, but there was also this component, property, event kind of thing. Can you elaborate on that a little bit?
Sure. Well, so Object Pascal sort of introduced the three cornerstones of object-oriented programming, you know, encapsulation, inheritance, polymorphism.
Right.
But it did not really have a system for writing components, and components is one of those words that can mean anything. But you know, it did not have a great model for creating sort of visual components that sit on a tool palette that you can drag onto a form and then manipulate properties in a property inspector and write code behind events. And that was, in a sense, Delphi's contribution to Object Pascal. The fact that we gave first-class treatment to properties and events in the language. And that made it a lot easier to create these software components that pretty much every visual development tool has today. It's still the same paradigm. You know.
We'll talk about that later in the context of C#. But to wrap this Pascal Delphi thing up, what's the state of Delphi today? Is it still in production? It's still used?
It's still there. It's still used. I mean, you know, trackers show it, but it certainly looks to be on the decline. Borland still sells. Well, it's now CodeGear, I think. But yeah. But you know, I have to say the Delphi user community. It's an amazingly strong user community, and I would still, you know, it's still a great Windows client tool. It really is. I mean, it's
.NET now, I guess.
They have a .NET version, although I do think that most customers probably still just write native Windows apps with or maintain existing native Windows apps. Yeah.
I've heard a rumor that the Condor soaring simulator is actually written in Delphi, but I have to follow this up. I don't know.
I wouldn't know. Yeah.
That would be a strange use because it's not at all a Forms Windows GUI kind of thing.
There are a lot of vertical segment Windows client apps written in Delphi. More often than not, you run across them in like you said, medical systems is what you said. I mean, that's like I've seen many of them there. Yeah. So.
Okay, so let's transition a little bit to the, let's say, more contemporary, at least your more contemporary stuff. Actually, in the beginning of the interview, I completely forgot to ask you to introduce yourself. Oh, so why don't we combine that? So you introduce yourself and tell people what you're doing today, and
sure.
You know.
So my name is Anders Hejlsberg, and I am a technical fellow at Microsoft. I work in the server and tools business unit, or more specifically in the developer division, where I am the chief architect of the C# programming language and also sort of the chief languages strategist, if you will, for Visual Studio languages.
C#, many people say is basically a cross between C++ kind of things and the Pascal Delphi world. So can you explain a little bit which of the, or how Delphi influenced or influences C#?
Well, I mean, there are, you know, you learn from your mistakes and your successes, right? And if something works, you keep it, and if it doesn't, you get rid of it. And so in some ways, you know, C# was the language I worked on after Delphi. Now I had a different company at Microsoft instead of at Borland.
Yeah.
And certainly something that had worked very well for Delphi was this formalized notion of properties and events. And I felt strongly that paradigm of programming with properties and methods and events, had become common enough that it ought to have first-class treatment in the language. And so that was one of the sort of core design tenets of C# was having properties and having events as first-class notions, as opposed to Java, say, where you have a pattern-based approach, and you sort of have to squint to see the properties, and ignore the get and set and the parens and the methods and so forth.
Yeah, and you don't have events at all. I mean, you don't have anything.
Right, you have listener interfaces and whatever, and then all sorts of plumbing instead.
Yeah. You probably know the Java Posse podcast. Maybe not. Oh well, you probably don't.
I've listened to a few of them.
Yeah, they have this guy Joe Nuxhall from Apple, and he is this great properties / event guy, and he wants to put that into Java by all means.
Right. Well, I mean, and there's the whole debate now in the Java community about closures, which really is sort of like the underpinning of events, if you will. It's function pointers or method pointers, if you will, and which C# has had from day one.
The syntax has been getting nicer over the versions, right? It will delegate blah blah blah, and now you can have real, more or less lambda expressions.
The syntax for writing them, but the underlying concept of a method pointer or a delegate or a method reference has been the same throughout. Yes. Although generics makes it a little simpler to declare them, because you can sort of declare one that's genericized and then just use that.
So C# today, we had a discussion with Eric Meyer on Link. So I think that's probably one of the most known current new features of C# and stuff that's kind of hyped. Right. Is there other stuff? I mean, in the positive sense.
Okay, good. There is a positive sense.
Well, okay, I'll retract that word. That's talked about a lot.
Sure. Yes.
So is there other stuff in current C# versions that you think is innovative compared to, let's say, traditional languages, or what's interesting for people to know?
Yeah, I feel pretty good about C#'s evolution. I think it's been very innovative in its various releases. 1.0 was sort of the baseline release but nonetheless that solidified things like properties and events as first class treatment. The unified type system where in C# everything is an object. And then later you can start sort of taking apart the particulars of value types versus reference types, but there's sort of this great unifying concept that anything is an object. And then in C# 2.0 we added generics, and these are reified generics as opposed to Java's erased generics, which I think history clearly has proven was the right approach. And I'm very happy with that work, and that was great work done by Don Syme and Andrew Kennedy from Microsoft Research. And now in 3.0, we talk about Link, because that's sort of the headliner. But the interesting thing about Link is that, first of all, it is built on top of generics, and generics is the deep enabler for Link.
How is that? I don't see the connection.
Let me talk about the others, and then we'll come back to why it is. But Link is actually an amalgam of language features, about 6 or 7 language features that come together to form this higher unity, So there are things in there like lambda expressions, like anonymous types, local variable type inference, extension methods, object and collection initializers, and so forth, and then query expression or comprehensions that we sometimes call them. And all of those come together to form this concept of language integrated query. But the thing that's interesting is that each of those features in and of themselves are quite innovative and quite useful.
Right. I knew of some of them, but I didn't put them under the Link moniker.
No, that is in a sense what Link is. Link is built out of those. And really the way Link came about, it's an interesting story, because I've always been fascinated with the impedance mismatch, if you will, between general purpose programming languages and databases, and the fact that here are these two each in and of themselves incredibly powerful worlds that are so different.
Yep.
And the way they marry is so horrible, right? I mean, it's like there's all this beauty in general purpose programming and all this beauty in the relational algebra and databases, and then the way you put them together is with these horrible APIs, right? Queries and strings and so I always felt like there's got to be a better way. And of course, one of the key enablers there is this notion of query. And I always felt that it was bizarre that you had this incredibly powerful query engine that only could be used on data stored in a database, right? But we have lots of data and in-memory arrays and XML documents and so. But the way LINQ sort of originally then got introduced in the language in our prototypes was just by hard coding syntax, like where and select and order by, like new keywords and you know, that compiles into certain library functions and whatever. But then we sort of gradually discovered that we could generalize this down to just discrete language features out of which you get the bigger whole. But then you know, it's often this way when you're doing new stuff in a language or any innovative field for that matter. You sort of plow forward with a prototype, and then you discover that the prototype is actually just sort of an instance of a class of solutions. And then if you have the courage, you back up and you put in place the class instead. Right. And we did actually do that. At one point in the project, we literally stopped. We took all of that stuff out, and then we put in more general concepts like lambda expressions and extension methods and so forth. And then we built it all out of that instead. And that was well worthwhile, I think. Yep. Now you asked why generics. Yeah. Well, so generics make the type system much richer, and it allows us to flow type information through complicated expressions. Okay. So in LINQ, when you write expression or when you write queries, you're really just sort of like in a fluent fashion dotting together operators, you know, where, select, order by, blah, 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 blah. These are all generic methods that take type parameters, and then the interplay between the arguments and the way the types flow from the arguments into the results and then become the input to the next operator, that's all powered by generics. If there were no generics there, it's like, you know, in order to write a generalized where operator, well, it would take, you know, I don't know, a function that takes an object and returns an object, and you know what I'm saying? You need cast, and you would have to cast everywhere. Yeah. And then very soon it would no longer look like a query language, right? So.
Yeah, the other thing is probably the type inference that you're able to
yes. So you got to couple it all, but you don't want to manually have to say the types, and of course this is why also in functional programming languages that there's so much type inference, because otherwise it all, you know.
Yeah, that was one of the early examples I saw of LINQ, that you did a query and then there was the result, which was basically a statically type inferred compiled anonymous type.
Yes.
Which you could access with a dot operator. You had code completion, everything, but you never ever said what type it was because it was anonymous. It was basically assembled from the fields you select.
Right.
That was actually really
so the
nice.
Type flows out of the query and into the for each that consumes the type down below.
Very nice. The other thing that I think is fascinating about LINQ is that it's basically its built-in metaprogramming facility, that you can get the AST and do something with it. That's something I think that's not very well known, or let's say that's not on the forefront of what people talk about.
Right. It is again one of these enablers. You know, when you think about like if you really want query to be a unifying concept where you write your queries in one way, and then the execution infrastructure decides how to execute. Well, sometimes execution isn't even going to occur on this machine here. Like in the case of an OR mapper, you want to take the query, turn it into SQL, and put it in a database, or turn it into, I don't know, some web-based query language and send it to Flickr or Amazon or whatever you're writing a link interface to. And in order to do that, you could argue that, well, maybe we should like reverse compile the IL, you know, for the predicate expressions and whatever that the user wrote, but that would be horribly complicated. It is not IL is not a very user-friendly format to grok expressions in, and so hence there was a need for sort of a formalization of expression trees.
That's really nice.
Yeah.
Since you mentioned before that you're the chief language guy, we have to talk a little bit about language design issues. And one thing we already talked about was this notion of components, so I don't think we have to revisit that. Another thing where I know that you have a very dedicated opinion about is exceptions, checked exceptions.
Right.
So are they good or are they bad?
Let me answer in two ways.
Okay.
I completely sympathize with the intent and the desire to have stronger type checking. I mean, in general, type checking or stronger compile time checking is a good thing.
Okay, that also answers another question I have later.
As long as it doesn't get in your way, and that is part two of the answer, is that I think, when you weigh the pros and cons, it's not clear to me that you made it better in the aggregate.
Mm-hmm.
Because checked exceptions have all sorts of problems, with this notion that you must either handle or yourself in your method declare that you rethrow all of these or push on these exceptions. And of course, if you look at the Java closures proposal, for example, it's yet another example of how checked exceptions just really make your world painful, and so maybe the dial was dialed up too high, and so we certainly felt that the solutions we knew of or that we could put in place in C# did not in the aggregate make it a better place to program, and so we remain neutral on that. We do not have checked exceptions. That's not to say that we don't look at having tools like fxcop and whatever that could do some analysis on your code and figure out whether you're handling all the exceptions and so forth. And that's something we continue to look into.
That's a good point. That's more like the middle ground.
Right.
You have a system that allows you to trace what's going on with a tool, but you don't require. Yeah.
Right.
Mm-hmm.
Right.
Plays also into this general trend of having more and more powerful static analysis tools with your language.
Yes.
Another thing that I wrote down is that I think if I look at C# and also at Delphi, then you're a big friend of making your intentions clear by specifying things like virtual override.
Yes.
So that you can cross-check whether, actually things fit together.
Right. Yeah, this was, again, actually, I think that a design we got right in Delphi and that was carried forward into C# is this notion that you must specifically say that you are overriding a virtual method. Like if you contrast it with C++ or Java, or at least in Java, you override a virtual method just by saying the virtual. Well, you don't. First of all, you never say virtual. Everything's virtual by default, which I also don't agree with. But you override the method simply by restating, and it's just the coincidence that you use the same name and signature means that it's an override.
Yep.
And that is effectively a sort of a versioning time bomb, because as a base class evolves, it is likely at some point to introduce a method with the same name and signature as a method that exists in a user-derived class that was written before. And now all of a sudden that becomes an override. But there's no guarantee that the semantic intent was the same here. And so now all of a sudden you're going to get calls to this method that you never expected to get. Or you're going to get, or worse, you're going to get compile time errors because the signature matches but the return type doesn't. And this has indeed happened as the Java libraries have evolved. This versioning bomb has gone off.
And how does the override modifier prevent that? I mean, because if you just write override. Oh, well, okay, I see. Of course, you cannot write override when at the time you write it.
When you say override, there must be something to override, or else you get a compile time error.
Sure.
Right.
Yeah.
And if you don't say override, then you introduce a new method here.
Yes.
And this method may have the same name and signature as one you inherited, but then you're just hiding that one. You're shadowing it.
Yeah.
So, yeah.
Are there other examples in languages of this kind of thing where you specify, with certain keywords or modifiers what's actually going on so that these kinds of things cannot happen?
Well, for example, the way we treat interfaces and interface implementations in C# also makes you be a little more specific about how you implement. And for example, we support private interface implementations where you can specifically implement this method of this interface, by saying interface name dot method name.
Oh, that's if you implement many interfaces in a class.
Right, and they so happen to they so happen to have a method with the same name and signature. Then in Java, there's no way to have these two implementations, and that also does happen, and it's also an example of sort of a versioning problem. So we try to in the design of C# think a lot about making it versioning resilient, because it's one of those things that sort of makes the language live longer. It's the kind of thing that doesn't matter at all in V1, and then as you come down like 10 years later, it matters a whole bunch, because they're big code bases and you have not painted yourself into a corner with respect to introducing new features.
I think a good example of seeing some of the consequences of that is the Eclipse platform. It's written in Java, and they have all kinds of evolution nightmares, blah, 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 interface, such and such, 2, 3, 4.
Right.
I'm obviously not everything is a consequence of those missing features.
Yeah, with interfaces in general, you cannot introduce new methods, because...
Sure, but it's also other stuff. It's also implementation.
Yeah,
it's just it shows this is a platform that is very long-lived, and they really have a challenge of handling the evolution of the things without breaking old stuff.
Right.
So let's look a little bit at languages of the future. Since you're the strategist, you have to know what they are.
Oh, I wish I knew the answer. Yeah.
So one provocative statement I've read several times, and is as long as it looks like C. So you can invent any language you want. You can invent any language feature you want. You have to use curly braces. Of course, that's a little bit cynical, but where do you think
Now, who made this statement?
Oh, I don't know.
Oh, okay.
It might have been Steve Yegge in one of his.
Okay.
I'm not sure.
Okay.
So what do you think are important concepts in upcoming languages?
Well, I don't think the curly bracedness of a language is gonna, and certainly you look at languages like Python and say F# and whatever,
Right.
and there are precious few curly braces in them. I do think that if you look at what is the underlying trend of programming language, if you go back like all of these 40, 50 years that we've had them now, and it's really the one thing that continues to happen is that we increase the level of abstraction of our programming languages. Right, we started with plug boards, and then machine code and assembler, and then C and C++, and now we're sort of in managed languages like Java and C#, and dynamic languages are seeing a resurgence and whatever, and so really I see no indication that is changing, meaning that really the next thing is going to be some upping up the abstraction level again, and the challenge is identifying what that new abstraction is going to be, and that's sort of largely influenced by what's happening in the industry today, which is that Moore's law has not stopped working, but it's changed in nature in that it's not going to give us higher clock speeds anymore.
Right.
It will still continue, and everybody thinks for at least 10, 20 years to increase density and capacity,
the
computing
overall
capacity.
power.
But it comes now in the form of more CPUs instead of faster CPUs.
Right.
It's really sort of like the bottom line, right?
Yes.
And that means all of a sudden concurrency is so much more important than it used to be. Now, concurrency's always been important in certain domains like high performance computing and whatever and graphics processing but now it's starting to actually become important to mainstream computing, because it is the only way that we're going to harness the power, so to speak. And of course, as a programming language designer, that means that we need to think deeply about how we can do better models for concurrency, because I firmly believe that the models we have today do not scale to general masses of application programmers.
Is one reason why I obviously agree, and I think everybody agrees more or less, except for the Erlang guys who obviously know. So is one reason why concurrency is so complicated today that it's not part of the language, but rather part of libraries. So it's hard to check, the compiler can give you only very limited support. You have a lot of protocols you agree to, as opposed to having formal specifications of things.
I think the big killer is state, or rather mutable state, you know, and we have effectively taught programmers, like generations of programmers, that, hey, state is wonderful and you're free to mutate it whenever you feel like it. Like, hey, declare yourself an array and then just start poking elements in there and in for loops and what have you. And and that's fine as long as everything executes serially. There's no problem. And then along comes concurrency and parallelism, and all of a sudden you have multiple units of work mutating the same state, and you can't even begin to reason about it. And there's very little in our languages that provide the necessary framework for reasoning about it.
Mm-hmm.
So in a sense, you could say, yeah, it's because it's API. Although, we do have locks or synchronization sort of as language features, but they're very low-level features.
Yes,
we do not have higher-level concepts like this thing is guaranteed to be isolated, or this thing is concurrency safe, whatever, or this function is pure, or this object is immutable.
Yeah.
A lot of these things are not language concepts.
Right.
And ideally, they should be, but we don't necessarily know how to make them. I mean, you could argue some of them we know what a solution might look like. They are pure functional programming languages, and they are indeed wonderful for concurrency. They're just not so wonderful for writing real applications. So that isn't the answer either, right?
Yeah.
But we can borrow some from there, and there are certainly parts of applications that don't need to be as mutable in their state management as they are today.
Yeah. At QCon 2 weeks ago, I saw Ted Neward's talk on F#, and then Simon Peyton-Jones's talk about Haskell. So, and they both, of course, are functional and ideally more or less pure functional. And they, of course, also talked about the fact that this is really great for concurrency. And I've heard many other talks that basically had the same message. But what I haven't heard yet is a talk that tells me, okay, here is functional stuff, and then there is the other stuff that has side effects, because at some point you have to have side effects. So what do you implement with which of those? How do you distinguish them? How much concurrency do you put in infrastructure/architecture, application servers and stuff? How much is necessary on the language level? Like if you look at Erlang, for example, the fact that it's functional is not really important. The fact that the reason why it is so good for concurrency is because it has this actor model.
Yeah,
it would be no problem if you had imperative and shared state within an actor.
Well, as long as it's isolated, right?
Yeah, right. But that's the whole point of actors.
But right, exactly. So Erlang formalizes the notion of isolation, or goes further in formalizing the notion of isolation. And once you have an isolated domain, then sure you can have mutation in there to your heart's content, because you're guaranteed that there's only one thread of execution at a time. And it's stuff like that where we have to, but then this doesn't really work. This doesn't help you one damn bit if you're writing, a data parallel application that's going to do matrix multiplication or whatever, right? So there are many different forms of concurrency, if you will, and we need to sort of push the state of the art there in coming up with programming models that are more suitable than what we have today. And then after that comes then formalization in the language of those programming models. In a sense, one thing that gives me hope is that with all of the stuff that we've done in my domain in C#, the language actually has become incredibly rich, and you can start experimenting with concurrent programming models simply by writing APIs. And APIs have become rich enough now that you can almost create little domain-specific languages just as APIs. Now, Link is an example of that.
Right.
We have another example in the Thread Parallel Library, or TPL, that our concurrency group is building. They're actually building two technologies together, TPL and plink, which is a parallel implementation of Link. And they're just APIs, but they're very rich APIs that take advantage of generics and type inference and so forth. And through those, it's almost like you can introduce new statements, like parallel.for. It's really a function, but you pass to it the body of code you want to execute.
Right.
So in a sense, it's like a method, right? Or like a statement.
So what I understand from that is that in addition to solving the concurrency challenge in future languages, I think having them more expressive, maybe through means of concepts borrowed from functional programming, and first class functions, closures and stuff, is probably another important step.
Well, it's important because it allows if you try to build a new programming model for concurrency by noodling with the keywords in the language, and you try to do all the language work up front, well, you have a couple of problems. One is you might get it wrong, and now you put some stuff into the language that you can never get rid of again. And now you've aged the language, and the language will therefore become irrelevant sooner. And that's a problem, right? Problem number 2 is that there's only you thinking about the problem, not your entire user community.
Right.
The other way around, instead of adding the instance to the language, you add the class that allows the users to create the instances, so to speak. Then you get a much broader user community experimenting in the field, and you can then, in a sense, as a language designer, cherry pick and go, wow, this thing is becoming very popular.
Yeah.
Maybe we should think about having formalized, like comprehensions or statements that are just a pattern over that API.
Right.
Like for each is, for example, in C#, right? It's just a pattern over using enumerators, and link expressions are just a pattern over the link API pattern. So that's sort of what I think is the better way forward, if you will.
So that also hints in the direction of metaprogramming / domain-specific languages.
Sure.
Before you said that you are a big fan of static typing. You didn't say it explicitly, but it became quite obvious. So how do you think metaprogramming DSLs goes together with static typing? I mean, most of the internal DSLs can be seen in dynamic languages like Ruby.
Right. Well, it's interesting because people just I like a little tangent there.
Sure.
I think one of the reasons that languages like Ruby, for example, or Python are becoming popular is really in many ways in spite of the fact that they are not typed. But because of the fact that they do very good metaprogramming support. Static typing is I don't see a lot of downside to static typing other than the fact that it may not be practical to put in place, and it is harder to put in place.
Yes.
And therefore it takes longer for us to get there with static typing. But once you do have static typing, I mean, gosh, hey, the compiler's going to report the errors before the space shuttle flies instead of whilst it's flying, right? That's a good thing.
Yes.
You get productivity tools like statement completion, which if I were to take that away from programmers today, I would be dethroned immediately, and someone else would be put in place, and they'd have to reinstate it, right? Because it is such a productivity tool, and better refactorings, require better knowledge of types, so. And static program analysis and whatever, performance optimizations, blah, blah, blah. I mean, there's a long laundry list of things that static typing is the enabler of. So I continue to think it's important. Now, with respect to DSLs, I don't know. We think a lot about DSLs, and I think there are a bunch of things we've already done in C# 3.0 that make it a better place for creating DSLs. Like expression trees is definitely an enabler there, and we will look at growing expression trees into becoming statement trees, where you can express full method bodies, if you will, as trees and pass them around as arguments and manipulate them and so forth. And in many ways, I think it's important for us to work on creating a better ecosystem, better APIs, better infrastructure for dynamic program construction. If you look at, people tend to think that, there's all this resurgence of dynamic languages and, we're becoming more and more dynamic, but we're actually doing very dynamic things with static languages. Look at something like ASP.NET, for example, which is huge dynamic programming system. You drop an ASPX page into a directory, and poof, someone notices that it's newer. It goes, recompiles it, turns it into native code that it then runs, but it's totally dynamic, right? But the way we get there sometimes through code generators and whatever is somewhat complicated. And we could have APIs that allows you to dynamically generate statically typed programs. There's another interesting thing there, which is this notion that we are all sort of wired in our heads to associate dynamic programming with lack of typing and static programming with strong typing.
Right.
And that doesn't have to be that way. And I actually think that the ideal place to be is static programming, but dynamically generated. If you follow what I'm saying. I mean, there's no reason why we should not do better type checking in a dynamic scenario as well, you know. So
of course, I mean, if you have this typical Ruby case where you call a method that doesn't exist and then you have method missing invoked or whatever it's called in Ruby,
right?
You know, I don't know how to handle this. What should I do?
Right.
You can't do this in a statically typed language because the compiler wouldn't let you call this method because it's not there.
Right.
So do you have to introduce some, let's say, type system holes like dot meaning instead of dot?
You could do it through dot. I mean, so. Yeah, you're sort of pointing out that I mean, but I will first say that, you know, the fact that you sometimes want to do something dynamic doesn't mean that it should always be dynamic, right?
I agree 100%.
So you could certainly speculate about formalizing the notion of dynamic dispatch in a statically typed language,
Right.
and that's something that I find to be very interesting,
Yes,
and something
so
that we might do in a future C#. Now we could do it through a special dot operator, or we could do it through static typing. We could say, if the thing you're dotting on is of a type that says I am dynamic,
implementing
then
the dynamic is
or
dispatch
whatever,
interface, whatever.
Then the dispatch is dynamic, right?
Yes.
So again, static typing actually allows you to do different things for dynamic dispatch, right? So yeah.
It's really interesting that you're thinking about this stuff, because that's stuff that I'm really interested in Scala. Because it feels almost like a functional, a dynamic language, very brief type inference and stuff.
Yes.
But it is not dynamic.
Right.
Because I'm not a fan of dynamic languages.
Right.
So a very interesting discussion.
Right. Yeah. No. This is, you know, I mean, I think one of the examples that people cite in C# 3 is local variable type inference, and the fact you just say var x equals something, and it looks just like JavaScript, you know, but it is actually strongly typed.
Right.
All right.
Yeah. So to come towards the end slowly but certainly, you said before that if somebody takes away the statement completion feature, then I'm basically screwed. Yeah. So I think one really important cornerstone in future language development is that there is no point in developing a language without thinking about the tool that you use to work with the language.
Right.
So can you talk a little bit about, in addition to statement completion refactoring, which is kind of obvious, how language design might change in the future when we take into account the tooling aspect as a first-class ingredient to language design?
That's actually a very fascinating area, and I've always been a strong believer in symbiosis between tool and language and framework.
You're right. That's the third ingredient.
That's sort of the and I mean, in a sense, if you look at like Turbo Pascal, I mean, it was about more tightly marrying those, right? And that was really what fueled its success, and that's how all modern IDEs look today. And I think it's foolish to think about one to the exclusion of the other, because in our day-to-day lives, you know, I mean, as programmers, we don't really sit there and make a distinction between whether this is a keyword or an API or whether, you know, I mean, it's just, you know, it's important for this to be deeply integrated. Now, what were you were asking about? How does it affect language design?
Or does it?
Well, it absolutely does. Here's a good example, like with link, and this is very, very relevant, really. If you program with link, you will have noticed that the select clause in a query comes at the end of the query. You say from blah blah blah, where, order by, group by, blah blah blah, and then finally you end with the select. Now, there are certain API reasons why that makes sense, because, you know, the select is the last thing you do, you know, but we could have certainly in our query comprehensions put the select clause first, like SQL does.
Yeah, select field 1, field 2,
select
field
blah
3,
blah blah from blah blah blah, where blah blah blah. But think about what the statement completion experience for that would be. Now here I am typing query equals select space. What do we show you?
You don't know.
What do we show you? What, everything that known to mankind, or we have no idea where things are coming from yet.
Very good point. Yeah.
But if you say from blah blah blah, you know, where, now we know what's in scope, so we can show you what and so that was one, you know, to us, deep motivator actually for putting things in the other order, if you will. VB9 in its original prototypes had the select clause first, and they did run into this statement completion problem, you know, and you would effectively have to write select, and then you'd sort of have to write from blah blah blah, and then go back to the select, and now you could get statement completion, and it didn't work so well.
Yeah, sure. That's a very nice example.
Yeah.
So another thing that I always think of, but I probably can't put it in words, is that somehow if you have a static language which supports meta-programming kind of things, that the IDE would have to understand all that stuff to a much deeper extent so that it could actually understand what you just meta-programmed you could take it into account, and the compiler knew that, I don't know. So I think it makes things more complicated.
Absolutely it does. And there is, I am fascinated by DSLs, but there's a part of me that also worries about DSLs because today we have to deal with one language, not 1,000 languages. Like in a sense, with DSLs, every program becomes its own language, right? And that could be dangerous,
or at least
for a variety
every domain.
of reasons.
I mean,
depending on how easy you make it and how much you push it and whatever.
Yeah.
So it's a tricky issue.
Yeah. So to wrap this thing up, do you want to mention a couple of interesting upcoming C# features? First published on SE Radio. No. I mean, but
no.
The roadmap. Is there any?
Well, I think in general, I can tell you that about the big influencers, right? And we've already talked about them. Like concurrency is huge, and we're going to do something. I don't know what the something is, but we're definitely thinking about it.
Yeah.
Domain-specific languages, metaprogramming, whatever. You've already seen us take steps there, and it's an important influencer. And dynamic languages are important, and when I say dynamic languages, I don't just mean like Python, Ruby, and whatever. I mean dynamic styles of programming, right? Mm-hmm. And that has lots of impact on C# as well, or will have impact on C# as well. But exactly what the features look, I couldn't tell you because I don't know yet.
Yeah, okay, that's fair. Yeah. Okay, anything else you want to leave our listeners with? Any pearls of wisdom?
Nothing comes to mind right now,
Okay.
but other than, as usual, we live in interesting times, and there we definitely, you would think by now that we'd be done, but the challenges just seem to get bigger all the time.
Yeah, that's a good thing. The more we know, the bigger the the challenge people want us to write software for.
All we can hope is just that we don't sort of fall victim to the old adage of you knew that it couldn't be done and therefore you never tried, right? I mean, but yeah.
Okay, Anders, thank you very, very much for the interview.
Oh, my pleasure.
Thanks for listening to Software Engineering Radio. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@seradio.net, or if it's specific to an episode, please use the comments facility on the website so other people can read and react to your comments. This episode of Software Engineering Radio, as well as all other episodes, are licensed under a Creative Commons license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.